Hello students, this is the last part of chapter 3, and the only thing we're going to go over in this video is limiting reactants, and I'm going to work through some problems, and there isn't a concept check here, but you guys will have plenty of practice with homework and the activity worksheet. So I first want to start out with an analogy. Limiting reactants basically are about a certain component limiting how much product can be made. So say you're making skateboards in your garage, it's your latest venture. You need a skateboard deck, 4 wheels, we're assuming the trucks are on there, but basically you have 20 decks, 85 wheels. What's the limiting component? You know it takes 4 times as many wheels. So you already know you just need 80 wheels, you have 85. So the decks are going to limit that. You guys could do that in your head quite easily. It's a little more tricky when you have a more complex equation and there are different components, a variety of components, as well as different coefficients and different numbers. So I'm going to go through some key examples, but this is all we're doing. We're just seeing what component limits it. And the main way we're doing that is finding out 20 decks can give you 20 skateboards, but 85 wheels could have given you more skateboards, but you didn't have enough decks. So the one that gives you the least amount of product is going to be the limiting reactant. And then we'll talk about what's in excess. Basically, you had way more wheels, you only needed 80. So the excess is what you started with, 85 minus 80, you'll have 5 wheels left over. So that's essentially what we're doing. I'm going to show that with some other problems. So the first is just a generic reaction, A plus 2B giving C. So get used to me using A, B, and C. I use this in your quizzes and exams, but instead of using actual formulas, I just use a generic compound A, B, and C. What this is telling you is 1A reacts with 2Bs to give you 1C. That's just in general, but what are the real amounts? I'm going to use 3.6 moles of A and react with 4.6 moles of B. And I want you to find the limiting reactant. There are actually a number of ways to determine limiting reactant. I'm going to show you what I found over the years is the easiest for students and most systematic. The first thing is find moles of reactants if you're not given moles. I gave you moles, but sometimes they're given grams, so you need to go an extra step, grams to moles, using molar mass. The next is use mole ratio to figure out how much product could be made. And you could do this in moles. So do it for A, how many moles of C, 3.6 moles of A can make, and then do the same for B. So I'll walk you through this. To go from A to C, the only way you could do that is mole ratio, which is 1 to 1. And that gives me 3.6 moles of C. So what that tells you is if I could react all of this A, I could make this much C. But I don't know if I could react all of A, just because, just like the skateboard example, I don't know which one's limiting. So I need to look at how much B can make. And I start with 4.6 moles of B and go B to C. And now it's 2 to 1. So it's different. Be very careful. You can never just look at the starting amounts and determine mole ratio that way. If everything's 1 to 1, yes, but it's not 1 to 1 here. It's 2 to 1. So I need twice as much B. And so in the end, 4.6 moles of B only could make 2.3 moles of C. That's the least amount. It can only make this amount of C, so it limits. It doesn't matter how many moles of A. I could have 1,000 moles of A. I'm still limited by the amount of B. So the least amount of C would be produced by B, and B is the limiting reactant. That means, just to let you know, this never happens. We could cross-scratch this out. This never happens because you cannot completely react this many moles of A. When I ask you later how much max product could be made, it's only 2.3. Never, ever, ever add these up. I see this all the time. It's only 2.3, scratch this out. So the excess we'll talk about more later in our next example, but what we'll do is use mole ratio to find out how much of that leftover reactant was used and subtract that from the original. And the theoretical yield, you already found this out. It's the max amount of product the limiting reactant can make. Something else that we look at is percent yield. And you'll do this a lot in your labs, both now and in future labs. The percent yield is what you actually produce in the lab, the actual yield, divided by the theoretical. So that's why the theoretical is important to know. It's the max you can make based on the limiting reactant when the limiting reactant is completely used up. And sometimes it's less than 100% yield because maybe you spilled something, or maybe the reaction had some byproducts or didn't react perfectly. So a lot of times a good yield would be 80 to 100%. This is a problem that we're going to go through, and this involves chlorine reacting with fluorine gas to give chlorine trifluoride. So I have a balanced equation below. You can check that. It is correctly balanced. And these again are relative numbers, so these aren't the real moles used. The real moles are given up here. I'm going to react 0.750 moles of chlorine with 3 moles of fluorine. I need us to figure out how to answer these 3 problems. What's the limiting reactant? What's the theoretical yield? And how much excess reactant remains? You guys can take a stab at this. You could pause and work these problems. I haven't shown you how to do the excess reactant, but you can try that as well. And then unpause and I'm going to go over it. So to find the limiting reactant, take each of the reactants individually and find out how much product can be made. So using the amount of chlorine, go chlorine to chlorine trifluoride, and that's a 1 to 2 ratio, mole ratio from the equation. I put the chlorine on the bottom to cancel, and I get 1.5 moles of chlorine trifluoride. So this can only be made if all of this chlorine is used up, but I don't know if it's the limiting reactant. Let's look at the 3 moles of fluorine. I'm going to go from reactant to product, put the fluorines on the bottom to cancel, and what numbers do I put in? 3 to 2. You have to look at the equation, get mole ratio from the equation, those cancel, and I get 2.00 moles of chlorine trifluoride. So looking at this, if all of this chlorine is used, I can make 1.5 moles of product. If the full 3 moles of fluorine is used, I can make 2. Which of these is going to occur? Only the upper one, because you're limited by the amount of chlorine. You don't have enough chlorine to produce 2 moles. You only have enough chlorine to produce 1.5. So the lower equation doesn't even happen. The only thing that can be made, max amount of product to be made, or the theoretical yield, is 1.5 moles. And chlorine is a limiting reactant. So you could scratch this out. This doesn't even happen. So again, this is the theoretical yield. And the next question that I ask you is how much excess reactant remains? So the excess reactant is fluorine. This never happened. I only used enough to make 1.5 moles of chlorine trifluoride. So to find out how much was left over, I need to find out how much fluorine was used. So the way I like to do that is start with the amount of product produced and go backwards. If I made 1.5 moles of product, for every 2 moles of product, I used 3 moles of fluorine. And that'll tell you how much fluorine was used. So I write that out here, what I just said. And then we're going to work backwards and from the theoretical yield. So I show this here, 1.5 moles of chlorine trifluoride, and just use mole ratio, put the moles of chlorine trifluoride on the bottom, and then it's 2 to 3 from the equation, 2 to 3. That's mole ratio from the equation. Moles of chlorine trifluoride cancel, and I get 2.25 moles of fluorine. That's how much was used to make 1.5 moles of this guy. So if I had made 1.5 moles, mole ratio tells me how much fluorine that came from or was used. So 2.25 moles of fluorine used to make that. So now to find how much is in excess, I just subtract it from what I started with. I started out with 3 moles minus 2.25. I end up with 0.75 left over. Okay, that ends chapter 3. You guys, please keep practicing limiting reactants, and I write out a tutorial online as well.